In this video, we are going to see construction of an analytic function. That is how to construct an analytic function when real or imaginary part is given. And this method is called as Milne-Thompson method. So here we need to have two formulas. One is when u is given, what is the formula to find the analytic function f of z. Similarly, when v is given, what is the formula to find the analytic function f of z. So the first formula is if u is given, f of z is given as integral ux, that is partial derivative of u with respect to x. So ux at the point z comma 0. So you have to find out ux at the point z comma 0 minus I into uy z comma 0 dz plus c. And then when v is given, the formula is f of z equal to integral vy at z comma 0 plus I into Vx at z comma 0 dz plus c. So here let us move on to the problem. First problem is show that u is harmonic and determine harmonic conjugate and find f of z. So what we have to do here is first thing we have to check whether this is, that is we have to prove it is harmonic. After proving it is harmonic, then we have to find out harmonic conjugate. And then we have to find out the analytic function f of z. So this f of z we have to find out using this Milne-Thompson method. So now let us start with the problem. So here let us start first proving that u is harmonic. To prove u is harmonic, we have to check for Laplace equation. So always we remember Laplace equation is dou square u by dou x square. This is a Laplace equation, dou square u by dou x square plus dou square u by dou y square is equal to 0. This is what we have to prove to show that u is harmonic. So here u is given as x cube minus 3x square plus 3x square minus 3y square. So here let us find out ux, that is dou u by dou x. So partial derivative of u with respect to x gives you 3x square minus 3y square plus 6x. Next is dou u by dou y. So what is dou u by dou y? It should be minus 6xy and then minus 6y, right? Next is dou square u by dou x square. So again we have to differentiate one more time with respect to x. So here it becomes 6x this term. Second term will become 0 and the third term will become 6x. Similarly here dou square u by dou y square is equal to, here with respect to y we are doing, so it is minus 6x. Similarly here minus 6. So if we add both the terms, we will get dou square u by dou x square plus dou square u by dou y square will be equal to 0 because right side 6x minus 6 cancel, plus 6 and minus 6 get cancelled. So which implies that here u is harmonic function. So the first part has been proved. Next we have to determine the harmonic conjugate. What is harmonic conjugate means? V is the harmonic conjugate of u. So we have to find out V here. To find V, we have to use Cauchy-Riemann equation. So what is Cauchy-Riemann equation is? Let us consider the Cauchy-Riemann equation, that is ux is equal to Vy and uy is equal to minus Vx. So already we have found out what is ux. So that is equivalent to Vy. So from this what we can take is Vy can be written as equivalent to ux. So what is ux? So if we move on to the slide, here ux is nothing but this one, 3x square minus 3y square plus 6x. So we can write it here. So 3x square minus 3y square plus 6x. So this we have to take it as Vy. We have to find V. So what we have to do here is we have to integrate this with respect to y. So while integrating with respect to y, we can obtain V, that is integrating with respect to y. So while integrating partially with respect to y, here this term becomes 3x square y, and here it becomes y square integration is y cube by 3. 3 get cancelled, so we can write it as minus y cube directly. Similarly here plus 6xy, and then plus we have to add one constant. So instead of adding constant c here, let us introduce a constant as f of x, since we are integrating partially with respect to y. So if you partially differentiate with respect to y here, automatically f of x becomes 0. So we'll be getting this term. So instead of adding c, we have to use f of x here. Now again what we have to do here is we have to differentiate partially with respect to x. Here we are integrating with respect to y. Next again we are differentiating partially with respect to x. So we will obtain vx here. So while differentiating it, this becomes 6xy, this becomes 0, and then here plus 6y, plus since we are differentiating with respect to x, this becomes f dash of x. Right? Now if you notice from the CR equation, Vx is equivalent to minus Uy. So what we can do, instead of this Vx, we can replace here minus Uy. So what is minus Uy is here dou u by dou y. That is minus 6xy minus 6y we have to replace. So let us replace here minus 6xy minus 6y. This is uy, but Vx is equivalent to minus uy. So what we have to do here is we have to include one minus here, right? This is equal to 6xy, 6y plus f dash of x. So what happened here is minus into minus becomes plus, and left side also we are having 6xy plus 6y. Right side also we are having the same term. So totally both the term get cancelled, and finally we will be getting f dash of x is equal to 0, which implies f of x should be a constant term. Let us take it as c, right? So since we have finally concluded f of x is a constant c, here we can substitute in this v. So v is equal to 3x square y minus y cube plus 6xy plus c. So this v is the harmonic conjugate. Harmonic conjugate of u. So this is the second part of the question. So the third part of the question is to find the analytic function f of z. So to find the analytic function f of z, we have to recall the formula. And since we have assumed u is given, we have to use the first formula. So let us consider the first formula to construct the analytic function. So f of z is equal to integral ux of z comma 0 minus I into uy of z comma 0 dz plus c. So this is a formula. So already we know what is ux, but we know ux at the point x comma 0. But what is ux at the point x comma 0 is 3x square minus 3y square plus 6x. Similarly, what is uy is minus 6xy minus 6y. So these two terms are at the point x comma y, but here we need ux of z comma 0. So which means that we have to replace x by z and y by 0. So if we replace here, this becomes 3z square minus 3 into 0 plus 6z we will be having. Similarly here, uy of z comma 0 will give you 0 because both the term contains y, so we will be getting 0. Now we can substitute this in the formula. So f of z is equal to integral, here it is 3z square plus 6z minus I into 0. So minus I into 0 will become 0, and then we have to integrate with respect to z and then plus c. So this is simply integration of 3z square plus 6z into dz we have to do. So integrating this, what we will have, 3z cube by 3 plus 6 into z square by 2 plus c. So here this 3 get cancelled. Again here we can cancel like this. So finally what we can conclude, it is equal to z cube plus 3z square plus c is the analytic function. So now we have constructed the analytic function using Milne-Thompson method, right? So again we can recall the problem. So here three things we have to find out. First we have to show the function u is harmonic, and we have to find the harmonic conjugate, and finally we have to find the function f of z. So here the first step is we have proved, to prove u is harmonic. So first step is we have proved that u is harmonic. Next step is to find harmonic conjugate. So to find harmonic conjugate v. So this is the second step. After finding the harmonic conjugate, here the last one is to find the analytic function f of z. So finally we have concluded the analytic function is f of z equal to z cube plus 3z square plus c. Now let us move on to the next question. If u plus v is equal to x minus y into x square plus 4xy plus y square, and f of z is equal to u plus iv, then we have to find f of z. So already we know how to find the analytic function f of z if u is given or v is given. But here if we notice, it is given u plus v. So combination of u and v. So here for this particular problem, we have to do slight modification. So let me see what to do here. So already we have fixed that f of z is equal to u plus iv. If we multiply I on both the sides, so I f of z will become iu, and then here it becomes I square, so we can write it as minus v. So what we are going to do here is we are going to add these two things. So left side will become 1 plus I into f of z. Right side, if you take the real part, it is u minus v plus I into, what about the real part, sorry, imaginary part, u plus v. So now this is again in the form of f of z is equal to real part plus I into imaginary part. So here what we can do here is we can use new notation capital F of z instead of 1 plus I into small f of z. And then this u minus v, the real part, we can consider as capital U. I into u plus v, we can treat it as capital V. Now this is of the form, the usual function f of z is equal to u plus iv. So here what is given, v is equal to u plus v. So in the question, if we notice u plus v is given, so according to this function, v is known. So now we have to remember the formula to construct the analytic function f of z if v is known. If v is known, what is the formula to find the analytic function f of z equal to integral vy of z comma 0 plus I into vx of z comma 0 dz plus c. So this is what we have to find. So now what about capital V? So capital V is nothing but here u plus v, which is nothing but the function given in the question. So for our convenient, let us multiply this and then we can differentiate it. If we multiply, then it will be easy to differentiate it. So we shall multiply this. So that gives you x cube plus 4x square y plus xy square. Again multiplied by minus y. So minus y x square minus 4xy square minus y cube. If we simplify this, it is x cube. Here 4x square minus x square y will give you plus 3x square y. Similarly, xy square and then minus 4xy square. So this gives you minus 3xy square. Apart from that, minus y cube. So now this is capital V. Right? Now we want Vy and Vx. So partially differentiate this with respect to x and y. So Vx is equal to 3x square plus 6xy minus 3y square. Similarly, Vy is 3x square minus 6xy minus 3y square. So now we want at the point z comma 0. So at the point z comma 0 is 3z square. These two terms become 0. Similarly, Vy of z comma 0 is equal to 3z square. Remaining terms are 0. Now we can put it in the formula. So capital F of z equal to integral Vy first we have to substitute. So Vy means 3z square plus I into Vx we have to substitute. Vx is again 3z square. That's it. Into dz plus c. So what we can do here is both are same term 3z square. Here also 3z square. Apart from that, we can write 1 plus I is common into 3z square. That is taking 3z square common, we can write like this. And then here 1 plus I as well as 3 are constant. We can take outside the integral. That is, we can write like this. 3 into 1 plus I integral z square dz. So now it is easy to integrate z square. Integration of z square is z cube by 3. So this is equal to 3 into 1 plus I. Here z cube by 3 plus c. So this 3 and this 3 get cancelled, and moreover, what is capital F of z? Capital F of z is nothing but 1 plus I into small f of z. So throughout we can cancel by 1 plus I. So if we cancel throughout by 1 plus I, here it becomes small f of z. Here it becomes z cube plus c by 1 plus I is again another constant. So let us take it as c dash. So this is the analytic function for which u plus v is given.